So now let's look at how to divide radicals. So you should remember that we can't have a square root in the bottom. It's not allowed. So we have to get rid of it. So we can get rid of the square root on the bottom by multiplying the top and bottom by the square root that's on the bottom. So let me show you. So here we have square root of 2 on the bottom, right? So we can get rid of it by multiplying by the square root of 2 on the top and on the bottom. And follow the rules for multiplying radicals. So what is 84 times 2? You should get 168. So we're going to end up with the square root of 168 over, now you should remember that anytime you multiply a square root by that same square root, you end up with what's under the square root. So we're going to end up with just 2. But just in case you forgot that, I'll go ahead and multiply 2 times 2, which gives us 4. Now we have to simplify. So does the square root of 168 simplify? Let's see. So we'll draw our factor tree. So what are some factors of 168? We have 2 and 84, and you could have chosen any of them. I'm just choosing 2 times 84. You'll still get the same answer either way. So 2 is a prime. What can 84 break down to? I'm going to use 2 and 42. 2 is a prime. What can 42 break down to? I'm going to use 2 and 21. And then 21 can break down into 7 and 3, and they're both primes. So we're done. We can't break down anything else. Now we've got to find our pairs. So what do we have a pair of? We have one pair of 2's, so I'm going to write 2 on the outside once and cross out only one pair of 2's. Do I have any other pairs? No. So everything else is going to go inside. So we have 2, 7, and 3. So the square root of 128 can be broken down to 2 times 7 is 14, and then 14 times 3 is going to give us 42. Okay, so the square root of 168 is the same thing as 2 square root of 42. Now what's the square root of 4? You could do the factor tree if we want to, but we know it's 2. Okay, so right now our answer is 2 square root of 42 over 2. Is there anything else we can do? We can cross out the 2's. We have a 2 on top and a 2 on bottom. So our answer is square root of 42. Okay, next problem. 7 plus 3 square root of 5 minus 10 minus square root of 3. Make sure you do not FOIL. This is not a foiling problem. Just because you see 2 sets of parentheses does not mean you FOIL. Look at what's in between those parentheses. A minus sign. So we're actually subtracting. So we're going to end up with 7 plus 3 square root of 5. And then distribute that negative. So minus 10. And then negative times a negative square root of 3 will be a positive square root of 3. So 7 minus 10, they're like terms, right? What is 7 minus 10? Negative 3. Now this 3 square root of 5, do I have another radical that has a 5 underneath it? No. So it'll just be 3 square root of 5. And then lastly, Square root of 3. Do I have anything with the square root of 3? Nope. So it'll just be plus square root of 3. So just look at it as adding or subtracting like terms. And that'll be our final answer. Alright, so number 6, we are going to FOIL. Because see, there's nothing in between these. They're directly beside each other. There's no plus sign or minus sign in between. So this is where we're going to FOIL. So 1 times 2 is 2. You could also use the box method. 1 times square root of 5 is just square root of 5. 1 times anything is itself. Negative square root of 3 times 2. Don't multiply the 2 and the 3. You're just going to put the 2 in front of that radical. The only time you would multiply the 2 and the 3 is if the 2 was under a radical. But the 2 is not. It's just a regular number. Now this one, negative square root of 3 times square root of 5. The 3 is under a radical, the 5 is under a radical. So you are going to multiply them together. So you'll get negative square root of 15. Do we have any like terms? Is there any way to get them to be like terms? Well, just for the heck of it, let's see if the square root of 15 will reduce. What are 2 factors of 15? We have 3 and 5. They're both prime, right? Do we have any pairs? No. So this is going to be our final answer. We can't reduce anything to make it like terms. Okay, moving on to number 7. So we have another division problem. We know we can't have a square root on the bottom. We can get rid of it by multiplying by that square root that's on the bottom. Make sure you multiply the 2 to the top and the bottom though. Okay, so multiplying 3 times square root of 24. Is 3 underneath the radical? No, so we have to put it out in front. The square root of 24 times the square root of 24. Anytime you multiply a radical by that same radical, you can just take out the radical. So it's just going to be 24. Now you cannot cross out these 24s. One's under a radical, one's not. That one under the radical has to stay. But let's see if we can reduce it by using the factor tree. So 24 is the same thing as, we can use 6 times 4. You could have used 12 times 2, either one. 6 can reduce to 3 and 2. 2 is a prime, 3 is a prime. 4 can reduce, not to that, to 2 times 2, and 2's prime. Alright, do we have any pairs? Yes, we have one pair of 2's, so we write 2 once, cross out that pair. Any other pairs? No, so we put 3 and 2 inside. So that will give us 2 square root of 6. Now going back up to our problem, we'll have 3 times, what's another way of writing square root of 24? 2 square root of 6. That's what it reduced to, over 24. Now, we can multiply this 3 and 2. 3 times 2 gives us 6 square root of 6 over 24. Now one last thing. Does 6 over square root of 24, not square root of 24, does 6 over 24 reduce? So 6 divided by 24, math, enter. Gives us 1/4, right? So we'll have square root of 6 over 4 as our final answer. Think of this as 1/4 here. So There's an understood 1 here. 4. So 1/4.